All right, good afternoon. Howdy. Are you wake up yet? So what a great day we have went through. I really enjoy it. And next, so my name is Peishu. I'm an IT manager. I work for Lehigh Hanson, and we are part of the HeidelbergCement group. So, so this talk I'm going to share with you the story we have adapting GitOps in our CI/CD pipeline to deliver microservices into Kubernetes. And based on the feedback we just heard from one of the panel's members, that we should take the best practice out of the title, I guess. So, but really what I was just saying is that I'm not saying this is absolutely the best way, but we just say we'll follow maybe the best industry practices, right? So about GitOps. Okay, so here's the agenda. So I'm starting off with the brief introduction with who we are and what we do, and also the introducing the high level microservice architecture of a digital platform, right? Then I'm going to spend the majority of time to talk about GitOps adoption stories. Then in the end, I'm going to share you a complete workflow of GitOps and also a live demo, right? Okay. That's better. Okay, a quick facts about our company. So HeidelbergCement is the largest building materials company in the world. So we've ranked number 1 in aggregates, material aggregates, and we number 2 in cement and number 3 in ready-mix concrete, right? The company was founded in 1874, which is 145 years old, and headquartered in Heidelberg, Germany. And we operate in more than 50 countries worldwide, and we have over 60,000 employees. So that's background about the company. And here's the high-level microservice architecture. So you see that central to that is we have what we call digital foundation. So really a Kubernetes OpenShift cluster. So we're running lots of microservices. Most of them are stateless services. On top of that, also we have several services. So we run MongoDB, Postgres, Redis, and RabbitMQ, and Elasticsearch, and other stateful data sources and queues. Right? So we also have services running on premises, those are not microservices, and also more like a legacy services wrapper as a REST API, so we can consume by the APIs inside the cluster. And the connectivity between the cluster running in Microsoft Azure Cloud and also services running inside our data center is established through the Azure side-to-side VPN. Okay, so we got this architecture and this background out of the way, so it's time. Let's talk about the GitOps, right? Before we jump into GitOps, so let's have a look at what the CI/CD pipeline looks like in your company before we adopt GitOps, right? So this is a very typical CI/CD pipeline, probably familiar to most of the guys, but conceptually is. So we use GitLab for a lot of things, right? So we use the GitLab to store code repo and also the Helm chart with configuration repo. We start with just single, for each service we have a single repo, store both code and Helm chart. And also we use the, GitLab has a built-in container registry, so we use that registry to store the Docker images. And we also started with the GitLab CI, which is just YAML file. Over here you can see the typical GitLab CI. We have a build, and this is a very simplified version. We have build stage, we have a deploy stage, basically CI and CD, right? So build stage, really just build an image and push into the Docker registry. And for the deployment stage, so we run, we run the script Helm upgrade command, right? And with -- install flag. So to make a sort of idempotent way manner to deploy the Helm release into the Kubernetes cluster, right? So this setup works for a while, but there are a couple of problems we found. The first problem is that if you use the Helm, you probably already learned this, that from Helm's perspective, when you deploy they call Helm release, basically after the deployment object is created inside Kubernetes cluster, the Helm will consider it success, right? Even so that you may find in reality that you may have some part just struggling to be ready status due to a number of reasons, right? But the Helm just say, I'm successful. So you look at the CI/CD pipeline and say, oh, this runs successful. However, your part may never be able to, out and running. And the second problem is that after deployment, even a successful one, so the artifact deployed into Kubernetes clusters, and nobody's monitor that anymore. So if, say, for whatever reason you screw up something, you did, like James earlier pointed out, say, if you delete something, right? By accident, if I thought I'm working my local cluster, but I point to production, or putting there, whatever environment, you accidentally delete something, then there's no trace of what's going on. You have to manually deploy it back, have to manually run the pipeline deployment to put it back, right? So there's no monitoring, there's no sense to reconcile your Helm child, which is your desired state, and the runtime object, which is the actual state. So that's exactly where we found the GitOps is the solution to this, right? So so what is GitOps? So let me ask you, so how many guys have used GitOps? So quite a few. So GitOps is a term coined by a company called Weaveworks. So what it is that I take that definition, it's kind of confusing. So this is the GitOps, my definition, right, in the layman's way. So what it is first of all, it's a Kubernetes specific delivery practice, right? So in which you use Git as a single source of truth to manage both application code and configuration, right? That's the definition. So, however, if you look at remember the previous slide just show you, we pretty much fit every definition, right? Every single definition here. However, we don't consider that's the GitOps practice, right? So then I added a second point, which was drive home, which is a GitOps tool must have a Kubernetes controller, which is responsible to constantly reconcile application status against the desired state, right? So if you have a visual, here's the pipeline. I just reconstruct the pipeline. I follow the GitOps principle, right? So first of all, I did a minor enhancement. So we separate the Helm child from the source code. Okay, so you have two repos. Therefore, also we remove the deployment stage altogether, and replace that by GitOps controller, what we call GitOps controller, right? So during that process, we have evaluated two leading GitOps tools. So one is called it's called Flux from Weaveworks. Another one is Argo CD from Intuit. So those are the probably most popular tools out there, right? So also it's not specified in the spec. Also for both of the tools, the care less about the CI part, which I'll talk about later, right? So it really just focuses on the delivery, right? So if you look at this diagram, right? So you configure your either Flux or Argo CD to monitor your configuration repo, right? So if you then you compare what you have deployed into your cluster. If any deviation detected, they will every 3 minutes, so they run reconcile loop, right? So they make sure they are in sync. Okay. So there is so we have evaluated both Flux and Argo CD. So basically, they both get the job done, right? So it's really a hard decision which one we choose, right? So we found both are good, but there are a few differences I want to point out. Which, first of all, the Argo CD comes with user UI dashboard, very nice UI dashboard. I'm going to show you a demo. And however, if you use the Flux, then you have to subscribe to their online version. It's called Cloud, right? But Cloud is not just dashboard; they have tons of other like orchestration management tool. But we don't have that subscription, so that's kind of one thing we have to consider, right? Then, however, the Flux does, in addition to monitor your configuration, like Helm chart configuration repo, also monitor your Docker registry. So whenever you have new tag, something changes there, they automatically sync your Docker registry with your configure repo, like Helm chart, for example, right? So if you use Argo CD, then you have to extend your CI pipeline to add an extra step to do that, run script, something like that. Then the last and not least, the difference is that what I call dynamic configuration. So something like HPA, VPA, or ESTL. So those technologies tend to change your deployed artifacts, like deployment. For example, the HPA, they may, according to your certain threshold being reached, they're going to either scale out or scale in. So the replica number is going to change, right? So that creates a conflict with your what's called the GitOps tools, right? The GitOps tools will try to say, hey, wait a minute, your configuration says you have 2 pods, you should run 2 pods, but I saw 5 pods. They'll try to delete the extra 3. So then you have HPA say, wait a minute, I need 3 to run, make it more scalable. So those kind of, so the way they handle it is very different. So at the time, the Flux, I searched Google, I searched the Slack channel. So the answer I found was that you just get rid of the replica load, right? In that YAML file. Well, that certainly works. I found the Argo CD has a more elegant way. So they use this. So they use this ignore differences annotation inside their CRD, and they call application. Okay, so then you can use JSON paths to specify which block or blocks, or which sections you want to ignore. You want the GitOps controller to ignore those differences, right? So that's what's better, in my opinion. Right? So if I'm interested, I have those expressions for both HPA, VPA, or HTML. Okay. Okay. So end of the day, we choose the Argo CD as our GitOps tools. So I just want to emphasize that Argo CD is not necessarily better than Flux, right? Both are very different. The reason we choose that is just because they fit our needs better, right? So we don't have, for example, we don't have the cloud subscription, and we do care about the CI, and we do care about those. We use ESTL, right? So we do care about those dynamic changes. Okay. But we're not done yet, so we still have issue with the CI part. So if you go back to this slide, so we still use this CI, GitLab CI, use a canonical build, as James pointed out. Canonical is from Google, which is a canonical build. However, we found that the canonical is quite slow. Most of the microservices are writing .NET Core, so it gets slower and slower, and to the point that each build takes from 4 to 6 and all the way to 18 minutes to build. That's really, very painful to watch, to say the least, right? Then, because we're using microservices, developer can deploy to every day, can multiple 5, 6 times, or 10 times. That's a lot of hours lost, right? So, then we have we have fixed that problem. So then we found that there's a build kit. We found that this technology called build kit, right? I'm sure you heard about that. Build kit claims that they are 3 or 5 times faster than Canonical, so we give it a shot. And also we said, because it's really hard to make build kit to work with GitLab CI, so then we said, why not give Tekton a shot, right? So Tekton, like Christy pointed out, it's a Kubernetes native building blocks, right? So it's a spin off from the Knative build, right? So we give Tekton a shot. And fortunately, we found this in the catalog. They do have a build kit template, so just grab that. And we were blown away by the results we see. So instead of 10 minutes or 18 minutes, so we cut down to like 3 or 2 minutes. The subsequent build really takes around 1 minute, which you can see in the demo. So we're very happy with that. Then, however, still not done yet. So if you play with Tekton, you'll find that, especially when the time when you validate the solution, there's no simple way to trigger the Tekton run, right? So we don't want to run kubectl or Tekton TKN command to do imperative way. We try to do declarative way. So then also there's no support for like a GitLab, right? So how can we check the Tekton pipeline from the GitLab, right? So then we found out, we made a decision that we have to write our own GitLab webhook, right, in Golang language. So we come up with this solution. We write a very simple and very lightweight, right? So here's what it end up, the final picture looks like, okay? So we get rid of the CI, GitLab CI pipeline altogether, replace it with Tekton pipeline, okay? Now Tekton, so because we're using Argo CD, so we have to take care of synchronize the Docker image tag with the actual configuration, the values file basically. So we add an extra update task. So inside the Tekton pipeline, they have considered different a set of tasks. Inside tasks, you have those they call steps, right? Then each pipeline, each task can associate with the resources. Could it be Git resources? Could it be your image resource, right? So they call pipeline resource. So this is the terminology. So this is final picture. And also for the webhook, so the webhook is configured to for the code repo. The code repo pointers webhook, right? So whenever developer make a commitment or make a merge request, which is a pull request, so we trigger this webhook. The webhook will create the pipeline resources and the pipeline run everything, right? So basically, we do a code generation from the webhook. So first of all, if we based on naming convention, you will follow the existing one, we just use it. If you don't, we just create from scratch, right? So this is run very well. So so it's time for the demo. Let's see. So in the demonstration, I show you how our microservices source code repo and Helm chart has its own repo. So we use naming convention, right? Basically the server name dash config is our configuration Helm chart repo. And then show you the Tekton UI. So Tekton has a nice UI, so you can see the build process in real time. And also we I'll show you the Argo CD UI. So if I make some change to the code repo, what happens, you'll see the pipeline will fire up right away, they call pipeline run. You can see that in real time. After they finish the build, they will save the changes, and they will modify the tag, the image tag from the configuration YAML, right? So when that happens, then Argo CD will pick it up and deploy a new pod into the Kubernetes cluster, so you can see that in real time too, okay? So let's run the demo. Okay, so first of all, this is the Argo CD UI, right? So I have this demo. I have two applications. So this is the PostgreSQL, which is then we have identity services. So identity services is a single sign-on service. We manage those issue token for APIs to protect the API. So the identity service has dependency on the Postgres, right? So for Postgres, we also use the GitLab to manage the Helm chart. We use we call upstream Helm chart, right? So if I expand this one, oh, so I click on wrong button. Go back. Okay. So it shows you the health status, right? If it's healthy or not. Whether it's synchronized. By the way, you can switch between manual synchronization. For production, if you don't want to automatic deploy, you can do manual deploy, right? So you can also, for this demo, I just configure as automatic synchronize, right? Then this is, for every artifact, it also has health radius, right? So those are check marks. So if you see that we have an application, they have an application concept, then they have this service deployment, right? Then this is pod, okay? So if I make a change to my source code, right, you will see the pipeline. This is the Tekton UI, right? You see the pipeline run. You can also dig into the pipeline run, see what's going on. Then after finishing, you will see, if I switch here, you'll see they create they kick off the synchronization process. They create a new pod and terminate the old pod, right? So let's give it a shot. Okay. So this is the microservices. Well, this is a real world one. By the way, I just copied to my personal GitLab account for demo. What's the real world code, right? So we have, this is SP.NET Core API. Okay. So if let's just change something on the fly, okay? Say, let's see, it's a to-do code review. I say, okay, code looks good. I just remove the comment, right? I'll make a commitment. Okay. So right away, so this webhook will trigger the pipeline run, right? So if you dig into pipeline run, by the way, as I said, pipeline consists of tasks, right? Pipeline run also consists of, in runtime to create a so-called task run, okay, corresponding object. So you can, because the pipeline will have two steps, right? So this is the first step, right? So you can dig into, so they can, by the way, the Tekton pipeline, so each task is really a pod that run a container, right? So this pod actually initializes itself, right? So, okay, that's going on. The first task is build, right? Look at that. So you can just like, that's what you saw in James' demo in the Jenkins. So this is a real pipe from the Tekton UI, which is awesome, right? So it's already run several times, so it takes about a minute or so. Then the second task will kick off, will push the changes. I mean, right, it's already done, right? First step. So second step, so yeah, change the tag. Okay, it's already finished. Then you can give it a couple seconds, so that the GitOps controller picks up, right? Automatically trigger the synchronization loop. Okay, so you see they create a new pod. When new pods become online, because we're using the rolling update, right? So they can terminate the old pod. Okay, so that. All right. So that's pretty much it. And so this is our entire GitOps adoption. It's really a start. We just got started, right? So it's a journey. It's not a destination. So that's other areas such as like advanced deployment, like canary and blue green and A/B testing kind of scenario. And if I go back to the chart, so both two have, they don't support out of the box, but they have extensions, right? So in ArgoCD, there's an Argo rollout, right? If you use wave Flux, there's a wave flagger. So they both do those advanced deployment. Okay, so question? No? Because I already answered your question. Oh, I just remember some questions earlier. You guys point out like how to deploy like microservices, right? Because I've done microservices for many years. So of course this Tekton is a new thing, right? But if you use Argo CD, actually it has this concept called application over application. So after apps, so it bootstraps, right? So after setting everything out, if everything like out of the loop, they automatically synchronize, right? So this is really good for like a disaster recovery scenario. So in which if it's something accidentally get deleted, don't worry, they automatically, because they monitor your repo, right? So automatically put it back. Okay. All right, that's all, folks.